Hello, this is the topic 2.3 worksheet help video. So let's talk about how we're going to go work through these out. We have some proofs, but they're not all proofs. First one is a proof. It says 1 is a complement of 2, so that means that 1 and 2 add up to 90. And 2 is congruent to 3, so that means 2 and 3 are the same. So before you even start a proof, you can kind of write out what's called like a flow proof. 1 plus 2 is 90. Those are complementary. From there, 2 is equal to 3. So the 2 becomes a 3 because 2 is equal to 3. And then if two angles add up to 90, then they're complementary. So that's what we're trying to prove. So it's real quick. It's just stating a fact, switching out the 3, and then stating a new fact. That's the proof. Alright, so angle 1 is complement of angle 2. That's given. 2 is congruent to 3. That is given. 1 plus 2 is equal to 90. That is part of saying that 1 is complement of 2. So this one implies this. So 1 is complement of 2 implies that they add up to 90. That's the definition of complementary, not supplementary. Complementary. And then 2 is congruent to 3 means that 2 is equal to 3. The measure of 2 is equal to the measure of 3. So this one implies this one by the definition of congruent. Now as we put it all together, we see that the 2 shows up here and it shows up here. So I'm going to rewrite 1 plus 2 equals 90 as 1 plus 3 equals 90. You can see that the 3 went from a 2 to a 3. 1, 2 to 3, 90. Substitution, as in I replaced the 2 with a 3 here. And then 1 is a complement of 3. That's back to the definition of complementary. Definitions work forwards and backwards. You can state that complementary implies adds to 90. You can also say adding to 90 implies complementary. So that is the first proof of the homework there. For 5 through 10, you have to name the property. So if segment PQ is congruent to segment ST and ST is congruent to UV, so that's kind of like a train of thought there. We have PQ congruent to ST, and ST is congruent to UV. So we're like cutting out the middleman. We're saying we can go straight from PQ to UV. That's the transitive property. This one, angle F is congruent to angle F. That's just reflexive property. You have to go through and name the rest. So go for that. Number 13, write a 2-column proof. Okay, so I'm going to put statements and reasons. These are your 2-column proofs. Everything has a statement and a reason. So the first thing we have is that given that GFH, so GFH, that's this angle here, is congruent to GHF, that's this angle here. So I can go ahead and mark my diagram put 2 little marks there, and go ahead and put that into my problem as given information. GHF is congruent to GHF angle. Whoops, forgot my angle symbol. Okay, we need to then get to that EFG, so this angle, and GHF are supplementary to this angle. So we need to get that this angle and this angle add up to 180. So we know that these 2 angles add up to 180 because they're a linear pair, and then these 2 are the same. So that means these 2 add up to 180. That's the proof. So first we're going to state that we have a linear pair right here. So we have EFG and angle GFH are a linear pair. I'm abbreviating. Feel free to abbreviate. A linear pair. And we're gonna call that given from the picture. Okay, we were able to pick that out of the picture that that's a linear pair. You could also use like the definition of a linear pair because it does meet the definition of a linear pair. But you do have to give a reason as to how you can state that that's a linear pair. Next, what do we know about linear pairs? So from the lesson, we learned that linear pairs imply supplementary. So we can now say that EFG and GFH are supplementary. That was the linear pair theorem. Again, abbreviate, feel free. Linear pair theorem. Alright, so we have that these two angles are supplementary. We need that these two angles are supplementary. Now, what needs to happen now is we need to, what does supplementary mean? Supplementary means that the measure of EFG plus the measure of GFH equals 180. That's what that means to be supplementary. And now we're just a couple steps away. We need to see here, we can substitute in not that one. We can substitute in, see these are the same, so we can take this and turn it into GHF. So these two are the same, but we just got to do one little adjustment before we can substitute in. This is the angle GFH. We need to substitute in for the measure of GFH. Well, we can fix that. We can say that the measure of GFH is equal to the measure of GHF. This is a picky thing by the definition of congruent. When you state that something is congruent, that means that the measures are equal. Forgot my angle symbol again. And now we can substitute. Now we can substitute these right here. So I'm just going to rewrite this statement one more time with a minor adjustment. Instead of GFH, I'm going to replace it with GHF. Thus showing, substitution property, thus showing that these two angles do add up to 180, making them supplementary. So we have the EFG and GHF are supplementary. So now we can finish, and you always put your thing that you're trying to prove at the very end. EFG and GHF are supplementary. And that again is the definition of supplementary. Two angles, if we prove that two angles add up to 180, then that proves that they are supplementary. Alright, so as a proof. Alright, use the diagram and the given angle measure to find the other three angle measures. So this is the buy one get three free situation. So we have the angle 1 is 143. You automatically have the rest. The vertical angle is 143. The linear pair has to add up to 180. Alright, so if you have 1, you automatically have the rest. Find the values of x and y here. So in this scenario, we can use the vertical angles to make an equation. 8x plus 7 is equal to 9x minus 4. You can do that with vertical angles. And we can also, so we can solve for x here. So subtract the 8x over, add the 4 over. get x equals 11. For these vertical angles here, you get that 5y is equal to 7y minus 34. Do the same algebra. I'm going to go rogue here and go negative. I'm going to subtract the 7. And now I'll divide the 2. So there's your answers for that one. Have fun with number 12. It's on you. 15 similar is what we were just doing. They made an error though. See if you can find their error in how they went about solving this problem. It's interesting right there. They added those. 19's another proof. Now this is called a paragraph proof, and it's the same thing as a two-column proof. It's just instead of statements and reasons, you're just writing sentences. So they have that 1 and 2 are complementary. So off to the side here, we could do a little flow action, flow diagram. So 1 and 2 add up to 90. 1 and 3 are complementary. So 1 and 3 add up to 90. When two things are equal to the same thing, so if this is equal to 90 and this is equal to 90, then this means that 1 and 2 is equal to 1 and 3, because they both equal the same thing. And then we can cancel the 1's off, and we now have 2 is equal to 3. So that's the proof. Now we just have to write it out formally. So we start with 1 and 2 are complementary. 1 and 2 are complementary, and 1 and 3 are complementary. By the definition of complementary angles, we can state that complementary means that 1 and 2 add up to 90, and 1 and 3 add up to 90. This is what we did here. 1 and 2 add up to 90, 1 and 3 add up to 90. Notice I use the measures. The measures add up to 90, not the angles. The angles don't add up to 90. The measures of the angles add up to 90. Alright, next. Now we took this info and then put them together. So you could call that substitution, as in you're substituting the value of 90 for 1 and 3. You call it transitive. You could say like A equals B and B equals C. So therefore A equals C. A couple answers for that. Transitive property is fine. And then we subtracted the 1's. And we got to the measure of angle 2 is equal to the measure of angle 3, because we're dealing with measures here. Now that the measures are equal, you can say that the angles are congruent by the definition of congruent. Alright, number 20. I'm going to leave that one to you. And I think we could be done here. Alright, good luck.